Dear friends, in this class let us discuss about the evaluation of minus 1 by p and 2 by p. We know that the Euler's criterion is for any order prime p, n by p converges to n power p minus 1 by 2 mod p. So by using this argument, here first we show that minus 1 by p equals minus 1 power p minus 1 by 2 minus 1 power p minus 1 by 2, that equals 1 if p congruence to 1 mod p, if p congruence to 1 mod 4, and minus 1 if p congruence to 3 mod 4. So this is the evaluation of minus 1 by p. Minus 1 by p is minus 1 power p minus 1 by 2, that equals 1 provided p congruence to 1 mod 4, minus 1 provided p congruence 3 mod 4. So how? Here, by Euler's criterion, this is Euler's criterion for any order prime p, n by p congruence to n power p minus 1 by 2 mod r. So by Euler's criterion, minus 1 by p congruence to minus 1 by p congruence to minus 1 power p minus 1 by 2 mod r. Agree? Okay. By Euler's criterion, minus 1 by p congruence to minus 1 power p minus 1 by 2 mod r. That means minus 1 by p minus 1 power p minus 1 by 2, that's congruence to 0 mod p. So that means p divides this difference, that is minus 1 by p minus 1 power p minus 1 by 2. But what is p? P is an order prime. So this difference b, so since p is an order prime, this difference must be 0. So either this is 0 or plus 2 or minus 2. Since p is an order prime, there is only one possibility, this difference should be 0. That means minus 1 by p minus 1 power p minus 1 by 2 is 0. That is minus 1 by p equals minus 1 power p minus 1 by 2. Okay. Then minus 1 power p minus 1 by 2. So there are two possibilities. Either it is plus 1 or it is minus 1. According as p minus 1 by 2 is even or odd. Then here minus 1 by p equals, consider minus 1 by p. So minus 1 by p equals plus 1 if p minus 1 by 2 is even. Okay. Minus 1 by p is minus 1 power p minus 1 by 2, that is plus or minus 1 according as p minus 1 by 2 is even or odd. Then minus 1 by p is 1 when p minus 1 by 2 is even. P minus 1 by 2 even means p minus 1 by 2 is equals some 2k. Agreed? P minus 1 by 2 equals 2k means p minus 1 equals 4k. P minus 1 equals 4k means p congruence to 1 mod 4. Agreed? So for minus 1 by p equals minus 1 power p minus 1 by 2 is 1 provided p congruence to 1 mod 4. Agreed? Okay. Now it is minus 1. Minus 1 by p is minus 1 when p minus 1 by 2 is even, that is p minus 1 by 2 is odd, that is p minus 1 by 2 is some 2k plus 1. P minus 1 by 2 is 2k plus 1 means p minus 1 equals 4k plus 2. That means p equals 4k plus 3. That means p congruence to 3 mod 4. So these are the two conditions. Minus 1 by p is minus 1 power p minus 1 by 2 equals 1 provided p congruence to 1 mod 4, minus 1 provided p congruence to 3 mod 4. So this is the evaluation of minus 1 by 2. Agreed. Now, by using this Euler's criterion, we try to evaluate 2 by p. So the result is, prove that 2 by p equals, evaluation of 2 by p, that is 2 by p equals minus 1 power p square minus 1 by 8, that equals 1, provided p congruence to plus or minus 1 mod h, plus or minus 1 mod h, minus 1 provided p congruence to plus or minus 3 mod h. For every order prime p, 2 by p equals minus 1 power p square minus 1 by h, that is equals 1 provided p congruence to plus or minus 1 mod h, minus 1 provided p congruence to plus or minus 3 mod h. How? So consider the following p minus 1 by 2 congruences. We have p minus 1 congruence to minus 1 mod p. Agree? P minus 1 congruence to minus 1 mod p. Means p minus 1 congruence to 1 into minus 1 mod p. Agree? Okay. What is 2? 2 congruence to 2 into minus 1 square mod p. This can be rewritten as in this way only for the sake of situation. 2 congruence to 2 into minus 1 square mod. What is p minus 3? P minus 3 congruence to 3 into minus 1 whole cube mod p. Minus 1 whole cube means it is minus 3. So p congruence to 0. P minus 3 congruence to 3 minus 1 whole cube mod p. So what is 4? 4 congruence to 4 into minus 1 power 4 mod p. Agree? Proceeding like this. Finally we have R congruence to minus 1 power p minus 1 by 2 into R congruence to p minus 1 by 2 into minus 1 power p minus 1 by 2 mod p, according as R is either p minus of p minus 1 by 2 or p minus 1 by 2. Agreed? Either R is p minus of p minus 1 by 2 or R is p minus 1 by 2. Agreed? So consider this p minus 1 by 2 congruences. P minus 1 congruence to 1 minus 1 mod p, 2 congruence to 2 minus 1 square mod p. Proceeding like that, R congruence to p minus 1 by 2 into minus 1 power p minus 1 by 2 mod p, according as R is either p minus of p minus 1 by 2 or p minus 1 by 2. Now consider the vertical multiplication. What is 2 into 4 into etc. On vertical multiplication, 2 into 4 into 6 into etc. into finally p minus 3 into p minus 1. Okay, congruence to 1, 2, 3, 4 etc. to p minus 1 by 2. 1 into 2 into 3 into etc. to p minus 1 by 2. Also means into minus 1 power 1 into minus 1 square and so on. So it is minus 1 power 1 plus etc. plus p minus 1 by 2 mod p. Agreed? Okay. So that means 2 is commonly taken outside. How many times are there? P minus 1 by 2 times. So it is 2 power p minus 1 by 2 into, what means? It is 1, 2, 3 etc. to p minus 1 by 2. P minus 3 by 2 into p minus 1 by 2. Congruence to again 1, 2, 3 etc. to p minus 1 by 2 into minus 1 power 1 plus 2 plus etc. plus p minus 1 by 2 mod. So that means 2 power p minus 1 by 2 into whatever the term inside this bracket, that is p minus 1 by 2 factorial. So 2 power p minus 1 by 2 into p minus 1 by 2 factorial congruence to, again here it is also, the first term is p minus 1 by 2 factorial into minus 1 power sum of the first n natural numbers. What is sum of the first n natural numbers? sum of the first n natural numbers, it is n into, sum of the first n natural numbers is n into n plus 1 divided by 2. So sum of the, since p is an order prime, so sum of the first p minus 1 by 2 natural numbers is p into p minus 1 by 2 by 2. So it is p square minus 1 by h mod p. Okay, 1 plus 2 plus etc. plus p minus 1 by 2 is nothing but p square minus 1 by h. P minus 1 by 2 into p minus 1 by 2 plus 1 and so on. So it is minus 1 power p square minus 1 by h mod p. Agreed. But p minus 1 by 2 is incongruent to 0 mod p. Agreed. P minus 1 by 2 is incongruent to, since p minus 1 by 2 is incongruent to 0 mod p. Why? Because p minus 1 by 2, p minus 1 by 2 strictly less than p. So from here you can conclude that 2 power p minus 1 by 2 is congruent to minus 1 power p square minus 1 by h mod p. 2 power p minus 1 by 2 is congruent to minus 1 power p minus p square minus 1 by h mod p. Okay. Now, but by consider the Euler's criterion. What is Euler's criterion? Euler's criterion says that for any order prime p, n by p is congruent to n power p minus 1 by 2 mod p. So we have the for 2 by p congruent to 2 power p minus 1 by 2 mod p. Agreed. 2 power p minus 2 by p congruent to 2 power p minus 1 by 2 mod p. But from here 2 power p minus 1 by 2 is congruent to minus 1 power p square minus 1 by h mod p. So combines we have, it is 2 by p congruent to this one, but this one is congruent to this one. So it is 2 by p congruent to minus 1 power p square minus 1 by h mod p. This is the first requirement. 2 by p is equals minus 1 power p square minus 1 by 8 means 2 by p congruent to minus 1 power p square minus 1 by h mod p. Okay. Now it remains to show that it is 1 whenever p congruent to plus or minus 1 mod h and minus 1 provided p congruent to plus or minus 3 mod h. That's the requirement. That's the final requirement. Okay. Now here 2 by p congruent to this one means 2 by p minus 1 power p square minus 1 by h congruent to 0 mod p. Agreed. So that means p divides this difference. P divides 2 by p minus 1 power p square minus 1 by h. Again, this difference should be either 0 or plus 2 or minus 2. Since p is an order prime, there is only one possibility, the difference should be 0. That means, since p is an order prime, the difference is 0, means 2 by p minus 1 power p square minus 1 by 8 is 0. So it is 2 by p equals minus 1 power p square minus 1 by h. Agree? But we have 2 by p. What is 2 by p? N by p. N by p equals plus or minus 1. Because n by p, legendary symbol, n by p equals plus or minus 1 if n is rp or n r bar p. Okay. So here, according to that argument, here 2 by p is also plus or minus 1. But 2 by p is minus 1 power p square minus 1 by h. So 2 by p, therefore 2 by p equals 1. When 2 by p equals 1 means minus 1 power p square minus 1 by h is even. Okay. 2 by p is 1 only when minus 1 power p square minus 1 by 8 is 1. That means p square minus 1 by 8 is even. So that means p square minus 1 by 8 is even. 2 by p is minus 1 when that means p square minus 1 by 8 is odd. Agree? But what is p? Since p is an odd prime, then we have p equals 8k plus or minus 1 or P equals 8k plus or minus 3. Since P is an odd prime, then P square minus 1 by 8 is even, or P square minus 1 by 8 is odd. Since P is an odd prime, then P is either 8k plus or minus 1 or P is 8k plus or minus 3. That's only for the sake of this argument. Now, when P equals 8k plus or minus 1, what happens? But consider this P square minus 1 by 8. What is P square minus P square? 8k plus or minus 1 whole square. 8k plus or minus 1 whole square means 64 whole square plus or minus 16k plus 1 all divided by 8 minus 1 plus 1 minus 1 all divided by 8. Agreed? Plus 1 and minus 1 are cancelling each other. What does it mean? 64k square plus or minus 1, that is 8 is common. So it is 8k square plus or minus 2k. 8k square plus or minus 2k. So, what is 8k square plus or minus 2k? 2k is an even, 8k square is even, so it is always an even number. So 8k square plus or minus 2k is even. That means P square minus 1 by 8 is even when P equals 8k plus or minus 1. P equals 8k plus or minus 1 means, come on, P equals 8k plus or minus 1 means P congruence to, come on, P congruence to plus or minus 1 mod h. P equals 8k plus or minus 1 means P congruence to plus or minus 1 mod h. Now when P equals 8k plus 3, what happens? When P equals 8k plus 3, P equals 8k plus or minus 3. So what about P square minus 1 by 8? P square minus 1 by 8 equals P square, again 64k square, 64k square plus or minus 2 into 3 into 8 plus or minus when P equals 8k plus or minus 3. So it is P square minus 1 by 8 is 64k square plus 6 into 2 into 3 into, so it is 6 into 8k plus 9, then minus 1 all divided by 8. That equals 64k square plus 8 minus 1, again 9 minus 1 8, so it is 8k square plus 6k plus or minus 6k plus 1. Agreed? So 8k square is an even, 6k is even, so plus 1, so this total is always odd. That means P square minus 1 by 8 is odd when P equals 8k plus or minus 3. That means P square minus 1 by 8 is odd if P equals, or P square as P equals 8k plus or minus 3. P equals 8k plus or minus 3 means P congruence to plus or minus 3 mod h. So the first condition is when P square minus 1 by 8 is even, that means 2 by P is 1 when P congruence to plus or minus 1 mod h, and 2 by P is minus 1 when P square minus 1 by 8 is odd. That happens only when P congruence to plus or minus 3 mod h. That is what we request here. Okay. So this is the evaluation of minus 1 by P and 2 by P. The result is important. So that is depends upon the Euler's criterion. Means minus 1 by P is minus 1 power P minus 1 by 2. That is 1 provided P congruence to 1 mod 4 and minus 1 provided P congruence to 3 mod 4. But 2 by P is minus 1 power P square minus 1 by 8. That is 1 provided P congruence to plus or minus 1 mod h, and minus 1 provided P congruence to plus or minus 1 3 mod h. Agree? So now let us consider another important result, which is Gauss lemma. Gauss lemma. So the statement is if n is incongruence to 0 mod p. If n is incongruence to 0 mod p, and consider the least positive residue mod p of the p minus 1 multiples of n. Least positive residues mod p of the p minus 1 multiples of n, that is 1n into 1n, 2n, 3n, etc. p minus 1n. Okay. If m be the number of residues which exceed p by 2, then n by p equals minus 1 power m. So this is Gauss lemma, and the proof is in next class.